All right, good morning or good afternoon. Today, what you're doing something that's totally different than we've done before. It's more of an individual review. Instead of doing stations moving around, you're going to actually be doing your own stations via me and you. It is on Edpuzzle. It's slightly different, like I said. You should have grabbed the papers off the counter. One is your vocabulary, and two is your stations sheet, but actually it's your study guide. You're going to follow along with me. You're going to fill in the blanks as I reiterate and reteach the lessons that we've learned this 9 weeks. Your test tomorrow will be 50 questions. It will be on SchoolNet or via paper, and you need to be able to study tonight on the website that I provided to you a couple of weeks ago for your populations and ecosystems test and oceans test. Um, I will go to that website so you can look at the websites, the PowerPoints along with the video notes, along with the Quizlet links and the different videos that I put inside the PowerPoints as well. All right, so make sure you have those papers, make sure they are front and back, and we're going to get started. All right, so station one is a little different. You are going to read over the vocabulary list that covers hydrosphere, ecosystems, and you're going to draw a circle around any vocabulary word that you are still unsure of. Read the definition of any word you circled at least 3 times. Be sure to go back and look over the circled vocabulary words when reviewing for the EOG or also reviewing for the test. You're going to see EOG throughout this presentation because we are going to revisit this particular um, station review in May when we start doing EOG review. All right, so station two is talking about objective 8E11. You all may not be as familiar with it, but you're going to read over the statements that are on your paper. You're going to fill in the blanks as you read them and follow along with me. All right, so this is talking more about the hydrosphere and the water. So water is one of the most common substances on the surface of the world, of the earth world. Um, it is a continuous cycle. It cannot be created nor destroyed. And we're going to talk further more about that. Water has unique properties that impacts the role it plays here on the earth. Um, it provides us food, shelter, water, not shelter. It provides food, water for us to be able to live. It's actually a habitat for other organisms as well. Um, and then also we learned about the energy resources. There's a lot of hydroelectric companies coming about that are using water to function. So the water has so many, it impacts everything here on Earth. These properties also include polarity, which means the uneven distribution of charges across a molecule. Okay. Then you have cohesion, is the attractive forces between water molecules. They work together, they connect. So think about a co-president and a president. They work together with the same position. Okay. You have adhesion, the tendency of water to stick to other substances. Think about an adhesive band-aid. It's sticking to your skin, that band-aid, that adhesive part of that band-aid. Surface tension, the force that acts on the particles at the surface of a material. Everyone's seen that picture of that water bug, grasshopper-like green insect that is sitting on top of that water. That is surface tension, okay? It's the force that acts on the particles and the surface of a material. Density is the measure of mass of a substance per volume, so D equals M divided by V. Same thing in math. Specific heat, the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Basically, it's saying it's the amount of heat that is needed, that specific amount, that specific degree. Also, talking about this objective, water is the only substance here on Earth that occurs naturally as a solid, a liquid, or a gas. Always remember that triangle. You have your solid, your liquid, and your gas. Okay? And it is often referred to as a universal solvent because so many other substances dissolve in it. Okay. You need water to make Kool-Aid. You need water to make sweet tea. You need water to make Gatorade. And Gatorade, y'all might be a little young, and they might still sell it at Walmart Food Line, but it comes in a powder form. And you can buy it like Tang, like the Country Time lemonade. You pour it in there, it dissolves. If it dissolves in water, water is a universal solvent. Okay. So section 3, we're continuing with this objective. So water distribution. Water covers approximately 71% of the Earth's surface. 71%. Okay. But remember, we're going to break that 71% down into smaller percentages because you have that 71% is broken down into fresh water, salt water. That fresh water is broken down into a further smaller percentage. So salt water. Most of the Earth's water, which is 97%, is not drinkable because it is salt water. Okay. We cannot survive with salt water. We gargle it with it to help our throat. And I don't know the exact reason why we do that. Mama always told me to do it when I had a cough. The ocean is salty because of the dissolved chemicals. They are eroded from the Earth's crust and they are washed into the sea. Okay, it's salt. That's why that, and some organisms can only live in that marine ecosystem, which is also salt water, and you should see that in your vocabulary. Salinity. When you see this word salinity, and some of you that did stay a couple of weeks ago when we reviewed for the test, remember salinity. What's the first word that you automatically see, even though it's not spelled correctly in here? You see the word salt. Salinity means the amount of salt in ocean's water, and the salinity is increased by evaporation or by freezing of sea ice. And then it decreases as a result of rainfall, runoff, or the melting of ice. Because think about the word dilute. That fresh water in that ice cap is melting and is diluting some of that salt. Okay. Think about as grandma, mom, auntie, they always put that water in the grape juice because it's so tart and bitter. They want to dilute it a little bit. Some people like sweet tea, but it's too sweet. So they put some water in it and it dilutes a little bit of that sugar. Sugar does dissolve in water because that's why it's a universal solvent. So that is why it decreases from rainfall because rainfall is pure, your runoff or the melting of ice. All right, so that fresh water that's broken from that 71% is the majority of fresh water is 3%, and it consists of ice caps, glaciers, and oceans. It's fresh. Nothing has been put into it. It's fresh. Okay. When you get when I want if later on in this video, I want you all to make a cheat sheet, and I want you to remember these percentages specifically. 71% earth surface of water, 97% is salt water, 3% is fresh water. Memorize those numbers because it's going to come in handy tomorrow in your test and for the EOG in June. Well, May this year. So your oceans, the oceans can hold and they circulate more water, heat, and carbon dioxide. Because remember, we breathe in oxygen, but we breathe out carbon dioxide. Then the atmosphere, although the components of the Earth's climate are consistently exchanged, it's a cycle. And some gases escape out of it, and it's exchanged in the atmosphere. It goes back and forth. Okay. Also, the heat energy that is stored in the ocean in one season will affect the climate almost an entire season later. That ocean and the atmosphere, they work together to form complex weather phenomena like the North Atlantic oscillation and El Nino. And some people think and that is the reason why we have hurricanes as well and tsunamis, things like that. The weather does play a role. The heat in the ocean and the atmosphere does start to circulate, and things do occur. Okay. All right, we're continuing on with the same objective. You should be out station 4 block on your study guide that you have been creating. So the water cycle. I know you all know the water cycle: condensation, precipitation, runoff, evaporation, transpiration. That might be a new word for you, but I know you all know the water cycle. So I'm going to briefly go through it to just remind you and brief you back on it. So you know the sun drives the entire water cycle. It's continuous. It does not stop. Okay. Condensation, remember, it cools and it rises, becoming the clouds, which eventually condense into water droplets that create that rain, that precipitation. The evaporation is when the sun heats the surface of water. It evaporates and it ends up in the atmosphere as water vapor. Okay, that the gas that's coming out, just like when you boil a pot of water. Precipitation, depending on the temperature of the atmosphere and other conditions, the water precipitates as rain, sleet, hail, or snow. Okay, I know you all know this, and I know it's a little bit boring right now, but make sure you are following along. Make sure you are listening, because I may add a little bit more detail. Okay, runoff is that's when the water flows over the surface of the earth in streams. Okay, groundwater is runoff that can also infiltrate the ground, which it can go into the ground and it builds, it accumulates, becoming groundwater. So that's why you have the puddles in the middle of the grass, because it accumulates, it builds itself, it infiltrates the ground, and some of it just stays there. All right, in the groundwater, and you have two vocabulary words we talked about. You have permeability, and that is the measure of the ability of a rock or sediment, and we'll talk about the definition of sediment next in April after spring break, to transmit water or other liquids. You have impermeable. That means water cannot get through that material. Okay, water cannot get through that rock or that sediment, and so that's what helps. That's what keeps the groundwater from to rise, and it sits there because that water can't get through at that particular area in the ground. So always remember, when you see impermeable, that means it can't get through. Okay, but then you have a river, and then permeable means it can get through. It's the ability it can. So you have river basins. And we didn't talk too much about this. It was not necessary to talk too much, but for your understanding, river basins, they encompass the entire land surface drained by the various different streams and the creeks that flow downhill into one another and eventually into one river. There's several river basins here in North Carolina. You have the Eno River Basin down in Durham when you're going towards Northgate or to 85, you pass Eno River. You have the Neuse River Basin. You have the Pamlico River Basin. Actually, Person County, here in Person County, there's 3 river basins that go through Person County. Either the edge of it towards Caswell County, Yanceyville, the edge towards Durham, and I believe the other edge going towards Virginia, Halifax, and South Boston. The final destination with the river basin of the water drain, the final destination of the water basically drained from that river basin is an estuary or an ocean. And estuaries, we're going to talk about it. I know you all know the definition of it, but everyone lives in a river basin. It's weird as it seems, but like I said, remember, we have 3 here in Person County. Even if you don't live near the water, you live on land that actually drains to a water source. And our actions on the land affect the water quality, the quantity for downstream as well. What we do here in Roxborough, Timberlake, Allensville, Samora, Virgilina, I guess that's the only places in here in Roxborough that I know of. What we do in those areas affect the water quality at Hyco Lake, Mayo Lake, the water that goes through our sewage or our well water. Okay, there's, like I said, well, there's 17 river basins here in North Carolina. Okay, All right, now we're moving to station 5, and we're moving to a different objective. So just continue to follow along, read over the statement, and fill in the blanks. So estuaries. Estuaries are areas where fresh water and salt water mix. Okay. And while they mix, they're producing variations, different levels, percentages of salinity. Remember, that's the saltwater intake, and high biological activity. You have some organisms that can live in both fresh and salt water. You have organisms that can only live in fresh water. You have organisms that can only live in salt water. And then this area, there's a huge organism activity, that biological activity. There's a lot of plant activity. Some plants can only survive in salt and freshwater mix. All right, there are one of the most productive ecosystems here on Earth because of that high biological activity. Since they are shallow, okay, sunlight penetrates to the bottom. This promotes plant growth, okay? There are good nurseries as they provide a protected environment for species to hatch and to grow in before they migrate to the sea to live out their adult lives. And another animal you automatically think of are those little cute little sea turtles, okay? They are a type of environmental filter. Is an environmental filter where plants and animals in that area filter pollutants out of the water. An example, oysters. Now, I don't eat oysters. To me, they're nasty. But oysters filter out those impurities out of the water as they eat, collect, collect the contaminants in their bodies. And then they produce that nice, pretty little pearl. Okay, even though these are not real, but they produce a pearl. So remember, estuaries is the fresh and saltwater mix. Estuaries, fresh and saltwater mix. Easiest way to remember it, you have, get a different color, I'll be blue. When I see estuaries, I see the ES here, the ES here, okay? And then you have a mixture of different letters in the middle, fresh and saltwater mix. You can come up with anything to remember it, just know estuaries is a fresh and saltwater mix. I think that was the easiest way to remember when you see that word, or you can think of something else. Uh-oh. There we go. All right, so at station 6, I'm going to talk about it as you're filling in the blanks, but make sure you listen. So more with oceans, the ecosystem part, there are innumerable individual food chains overlapping and intersecting to form complex food webs. Remember, food chains are multiple, you have multiple food chains, okay, that create the food web, okay? And I'm going to try my best to do this, but I think you get the point. The ocean has the most unique ecosystem. You have most marine creatures create a variety of foods. If one link in a chain is depleted or disappears or it shrinks, other consumers, the ones that we eat, that's consumers are things that eat other things in the chain, can alternate food sources. So that's why the ocean ecosystem is so unique. If you have, for example, shrimp, if it goes away, one, we can't eat it, but then you have other organisms in the ocean that won't be able to eat it, but they're going to find a different food source. Like if we go on a diet, you can't eat red meat, but you can eat chicken. We can still survive off different forms of different alternate for food sources, okay? Ocean food webs are also connected to land-dwelling organisms, okay? Also, with the wind, we didn't talk too much about this because you talked about it last year, but there's one word in particular we're going to discuss. So winds have a powerful effect on the ocean and are important forces in creating ocean currents. Under certain conditions now, a special kind of ocean event known as upwelling can occur. Sorry. So upwelling happens when the warm surface water near the coastline is blown offshore by the winds, and the cold water along the bottom of the ocean near the shore rises. And so it's in a weird. I'm gonna do the blue color because it's the ocean. So we have. Let me see if I can do. Let's see. We'll do black as the shore. So we have the shore. Just channeling here's our umbrella, and we have the ocean, and I'm gonna use a red so y'all can see it. And it's going in the direction going up. Keyword upwelling. And while it's doing the upwelling, it's bringing all these different organisms to the top. It's bringing everything from the bottom all the way up to the top. It carries sediment like the rocks and things, seashells, and nutrient. It brings all that nutrients to the top. There was a question on your test from last week or 2 weeks ago that asked about the fishermen. Did the fish, if a fisherman goes fishing and there is an abundance of nutrients at the top, are you going to have more fish coming to eat that food? The question is yes. And the fishermen is going to be able to have more fish to catch because all those nutrients are at the top, and those fish are going to want to eat those nutrients in order to survive. Okay, so the upwelling brings nutrients to the top, more fish, more other organisms are going to come up to the top to eat those nutrients. And that's why we're able to catch the shrimp, catch the crab legs that are so good, catch the fish, and different animal organisms in order to eat. That's our consuming of alternate food sources. Okay, and I'll clear that, and I'll give you all a couple of seconds to get that rest written down. I hope you are following along with these notes. We're on station 6. We're about to start station 7. All right, so we're still on station 6. My fault. So dissolved gases. We talked about this as well. The action of the ocean wind that we just previously talked about, and those waves of the ocean surface, they're being stimulated, and they exchange all the gases between the ocean and the atmosphere. The marine plants that live in the ocean depend on that dissolved carbon dioxide in order to perform photosynthesis. Remember, plants do the complete opposite of us. We breathe in carbon dioxide and breathe out. We breathe in oxygen, breathe out carbon dioxide. But the plants do the opposite. They breathe in the carbon dioxide, they breathe out the oxygen. By breathing out the oxygen, we need the oxygen in order to live. And that's why you see a lot of environmentalists fighting with the companies because they're cutting down our trees and interrupting different habitats. If you cut down the trees and they need oxygen, they breathe out the oxygen, the carbon dioxide that we breathe out, we can get the other oxygen, the clean oxygen, in order to survive as well. Um, Marine animals depend on dissolved oxygen as well in order to perform cellular respiration. And we talked about the nitrogen cycle and the carbon cycle. You have cold water holds more gas than warm water. And seawater with low salinity that has low salt levels holds more gas than high salt water. The deep water, which has a high pressure, holds more gas than shallow water. Okay, I know it's a whole bunch of mixed up vocabulary, but just know that these organisms in the ocean, they need the dissolved gases in order to survive, in order for photosynthesis to occur, in order for cellular respiration to occur. Okay. All right, station 7. So the deep oceans. Traditionally, scientists have used ships to photograph the depths, to drop floats and drifters into the currents, and to collect samples of water, rock, and marine life. In recent years, the spectrum of available observing tools has grown to include human-occupied submarines, remote-controlled vehicles, and an autonomous robot. So we're able to go further down into the darker part of the ocean, the deep ocean, that we cannot physically get down to. There's material that they're investigating, they're creating daily in order to be able to survive down there because there's less oxygen the further you go. All right, so station 8, a healthy water system is determined by the balance between physical and chemical variables. Now we're talking about water quality. Physical variables that include temperature, and the temperature determines the kinds of organisms that can survive because particular aquatic, the water species, have preferred temperature ranges. Very warm water may not contain enough dissolved oxygen, and that's a variable that tells us if it's healthy or not. Can it be balanced? Turbidity. Now, this word I want you to always remember. Turbidity. It's a funky word. It looks like a dirty word. That's the good thing. Turbidity is considered a good measure of water quality. Remember, there's a picture of 4 or 3 different glasses from clear water to the cloudiest, dirty water. That's what turbidity is. It's the water quality, the clarity, how clear the water is. So, high turbidity can lead to an increased water temperatures, low dissolved oxygen levels, and even physical impairments of aquatic organisms, as water organisms that need to survive in that environment. Station 9. So the chemical variables, we already talked about the physical, the chemical variables, that dissolved oxygen that we talked about earlier, the balance in water is important for the survival of certain microorganisms and higher organisms such as the zooplankton and the fish. pH, we talked about pH levels. You have a pH scale from 0 to 14. That pH of the body of water is important because it has synergistic effect. This means that the impact of other materials in the body of water, such as iron, aluminum, ammonia, and mercury, is amplified. It's been pushed to its extreme, or it can be diminished. It can go away depending on the pH of the water. For example, when acidic water comes into contact with certain chemicals and metals, it makes these chemicals and metals more poisonous than normal. Acidic is not good, okay? You have nitrates and phosphates that are essential plant nutrients. Plants need these to survive, and they get it from the ground, that soil. The major sources of the nitrates in surface water include the runoff, and it can be contaminated with fertilizer, your septic tank leakage, your sewage, and erosion of natural deposits are a chemical variable in making sure our water is the water quality is good enough and safe enough for us to drink and to bathe with and to clean with and to cook with. The phosphates usually enter waterways from human and animal waste, laundry, and cleaning and industrial influences. And then you also have the salinity. We can't survive with salt water. We can't drink salt water when we get sick. Okay? Those are all chemical variables within our water quality. Station 9 as well. The bioindicators can be used to assess the quality of water. Break down the word bioindicators. What does bio mean? Bio means life, living. You see the word biology. Indicator is something that you use in order to find something out. So the presence and the condition and the numbers of the types of fish, insects, algae, plants, and other aquatic life provide an accurate information about the health of freshwater, coastal, and marine waters. Okay, so you put those indicators in there to assess the quality of water. All right, we've moved on to station 10, and this is also with water quality, and it describes the chemical, physical, and biological characteristics of water. Is it safe to drink or even to use? Here in the United States, we have an EPA, which is the Environmental Protection Agency, and this sets maximum levels of 90 commonly occurring contaminants. The EPA actually sets out a guideline of standards for a body of water to be identified in its uses, establishing how to protect it and how to preserve the water bodies in the long term. So drinking water treatment requires some basic steps. And you all watched the Diary of Jay-Z, and remember Jay-Z went to Africa, provided like a carousel like thing in order for them to be able to collect water in order to drink and to cook with. And sorry. And and it was a treatment. It went through a treatment so it could be safe. Instead of having to drink it out of the river, the stream where the animals were urinating and you had feces and you had bugs in there. The EPA makes sure that the water collection process is safe. The coagulation, that is when during lime and alum are added to the water, causing particles to clump together. And the water is shaken to form larger clumps. And during the sedimentation process, water stands for approximately 24 hours. And 24 hours is a long time, which allows the clumps to settle to the bottom. The water is then filtered out, disinfected, usually with chlorine, and is aerated. The substances removed during that drinking water treatment process includes suspended solids, bacteria, algae, viruses, fungi, minerals, and chemical pollutants. Okay, that's what a lot of people get the is it the Beretta thing you plug into your sink and it filters out because you can never be too safe. Okay, but it takes 24 hours to filter that water to collect it for the water to go through that treatment process. Okay, think about shaking out, looking for gold or money when you go to the beach. People put the sand on the little shaker and you shake it until you have what you have left out. Think about it; it's the exact same process, but it's water. So you can't shake the water, but it clumps together. They have something in there to clump that stuff together. All right, Station 11, we're talking about the ecosystem. This is a review. You all had the ecosystem down pat. I was so proud of your test scores from last week. You all know what a consumer is. You know what a producer is. You know that pyramid. You know the different energy levels. Excellent job on those questions. Again, some of you all might need to go back and review this stuff. You have all your notes. You have all your worksheets. I'm still grading some things, but you have all this stuff. So the ecosystem is a complex, interactive system that includes both biological communities, biotic and physical, abiotic. Populations, a group of organisms that belong to the same species that live in a particular area. The regulation of a population is affected by the limiting factors that include biotic and abiotic. Okay, remember, biotic means living, abiotic means non-living. Examples of abiotic: water, nitrogen, oxygen, salinity, pH. Biotic, all living components of the ecosystem: bacteria, fungi, plants, and animals. Station 12, organisms in an ecosystem consistently interact. They generate stability with the ecosystem. They can facilitate or restrain growth. They can change both biotic and abiotic factors of the environment. Predation, remember, an interaction between species in which one species, the predator, eats the other, which is the prey. As the prey population increases, the predator population increases. As the predator population increases, prey population decreases. All right, so competition. Remember, competition is a relationship that occurs when two or more organisms need the same resource at the same time. What y'all do in the cafeteria? Y'all fight over food. Y'all need the food at the same time. There's two or more of you all fighting for it. Asymbiotic relationships, when two different species that live together in direct contact. Remember, parasitism. One benefits, the other one does not benefit. So think about a tapeworm, fleas, a tick. You have mutualism, when both are benefiting. Think about the alligator with the bird in his mouth. The alligator is getting its teeth cleaned while the bird is eating off of that food. Okay? Commensalism, when one organism benefits, the other doesn't benefit, nor does it get harmed. So birds following ants. It's a little weird analogy, but think about it. Imagine it. Station 13, this is the last station. The energy, we just talked about it. The sun is the ultimate source of energy. It's transferred into chemical energy through the process of photosynthesis. Energy then passes from organisms to organisms. Energy can change from one form to another. And animals can get energy from oxidizing their food, releasing some of the energy as heat. Over a long period of time, matter is transferred from one organism to another repeatedly and between organisms and their physical environments. Food chains, food webs, and pyramids all are used to show the flow of energy through the ecosystem. A food chain is the simplest path that energy takes through the ecosystem. Energy enters an ecosystem from the sun. Each level is transfer of energy through an ecosystem called the trophic levels. You have 3 different trophic levels. You have the producers, your trees, your plants. You have your second trophic level, your primary consumers, your herbivores. Your third is your consumers. Again, your carnivores and omnivores, us, the wolves, the frogs, the owls. The food web, remember, is multiple food chains together. Your energy period represents the energy available for each trophic level in the ecosystem. Okay, you can go ahead and continue to read through this, fill in your blanks. You got this information. Like I said, I was very proud of you all with this part of their test. Continue to study, make me proud. Tomorrow, for your end of the 9 weeks, I want to see 70s or higher. I know you all got this. Okay, make sure you study tonight. You can pause it, rewind it. I'm updating grades. You all did phenomenally this third 9 weeks, following along with what I had planned for you guys in Miss Crawley's class, along with mine. We got the next stretch. We have the month of April, beginning May 1st. Crunch time, EOG review. You have this Ed puzzle. You can watch it. It's on YouTube as well. Have a great day.